Welcome to this explainer. Today, we're unpacking a groundbreaking AI engineering feat that basically validates a radical shift in how we govern intelligence itself. We're moving out of the trenches of silicon verification and straight into the deep meta-theoretical frameworks we actually need to survive the coming AI era. Let's dive right in.
Here is our roadmap. We'll start with AI's hardware design revolution, tackle the continual learning problem, and look at the end of truth-seeking. Then, we'll enter the Bridge360 MetatheoryModel, break down entropy-driven altruism, and finally, wrap up with governing the AI ecosystem.
All right, Section 1, AI's hardware design revolution. Let's start with a highly practical, real-world breakthrough. 580,430. I mean, just let that absolutely staggering number sink in for a second.
What makes that figure so wild is that this massive verification stack wasn't built by a giant corporate team over several years. Nope. It was built by a single engineer, Thomas Alla, working with a suite of AI agents in just 43 days. We're looking at the 3% to 20% to 80% Pareto principle recursion operating in hyperdrive here. A tiny fraction of human effort is being amplified recursively by AI to generate the vast majority of a foundational verification stack. It's a true game changer.
Moving to Section 2, the continual learning problem and the recursive loop. This incredible speed brings up a much more dangerous phase.
So this engineering feat kicks off a bounded, recursive acceleration loop across software and silicon. Step 1, AI agents improve electronic design automation tools. Step 2, those better tools design specialized AI chips faster. Step 3, stronger chips run even stronger AI agents. And the loop repeats. Now this puts us face to face with Turing's halting problem and Church's undecidability of first-order logic. In a closed loop where the system constantly rewrites its own foundational logic, it's mathematically undecidable if or when this acceleration will safely halt.
Because of that, a static, one-time safety checkpoint completely fails. The more adaptive the intelligence, the more necessary continuous corridor governance becomes. Think about Gödel's incompleteness theorem here. No sufficiently complex, evolving system can prove its own consistency or safety entirely from within. You can't just freeze the weights, slap a safety stamp on it, and walk away. The intelligence is a constantly moving target.
Section 3, the end of truth-seeking. This systemic fragility throws us right into a Kuhnian incommensurability crisis. The Duhem-Quine thesis tells us we can never test a single hypothesis in total isolation. The whole interconnected network of AI logic is shifting at once, meaning we need a total pivot away from classical epistemology.
For centuries, our normal science relied on classical truth-seeking intelligence, the idea of forming a perfect one-to-one map of reality. But, as Laughlin's emergence thesis shows us, hyper-complex systems develop emergent behaviors that simply can't be reduced to their individual parts. Information spaces become computationally intractable. So instead of chasing absolute truth, we really have to rely on Vopnik's weak convergence thesis. We don't need perfect mapping, we just need the system to weakly converge on safe, stable states. We call this entropy attractor intelligence, basically minimizing entropic blowout while working under a finite budget.
It's exactly like diving in deep, murky water. Lorenz's chaos theory pretty much guarantees that trying to perfectly map every single swirling particle around you is a total fool's errand. You'll just run out of oxygen and drown. But the diver who just follows the macroscopic entropy gradient, knowing that the bubbles always rise to the surface, survives. When AI hits critical transitions, the time you need to perfectly model the system is way more than the time you actually have. Survival relies on navigating the chaos, not mapping it.
Okay, Section 4. Enter the Bridge360 MetatheoryModel. To manage this continuous adaptation, we need a radically new framework.
Instead of chasing ultimate metaphysical truth, Bridge360 secures the AI ecosystem using structural governance slots. It's essentially a grammar for bounded survival. We use spine corridors to strictly define where the AI is allowed to operate. We use K-budgets and leakage metrics to measure exactly how much uncontrolled chaos the system is bleeding out into our environment. It acts as a handshake protocol, inviting engineers to fill those slots with hard computational math to lock in operational bounds.
Moving to Section 5, Entropy-Driven Altruism Explained. Now we zoom in on the systemic, social solutions that keep these hyper-complex systems from tearing themselves apart.
Within this new paradigm, we encounter rule of inference mimetics. Think about Bayes' theorem for a second, how we continuously update our beliefs based on new evidence. Now, imagine those Bayesian inference rules acting as physical, tokenizable replicators, almost like viruses spreading across a neural and computational substrate. When AI agents write code that verifies the next chip, any hidden logical virus can propagate recursively through the entire tech stack.
Building right on that, we arrive at entropy-driven altruism. This thesis shows that cooperative behavior isn't just some nice moral puzzle we need to solve, it's thermodynamically mandated. When coupled feedback loops approach critical fragility thresholds, purely individual competition guarantees total collapse. Cooperative, corridor-preserving adaptation is literally required by the laws of physics to prevent systemic blowout.
Finally, Section 6, Governing the AI Ecosystem. Let's synthesize all these concepts and bring it all together.
Thomas All's trajectory maps perfectly onto this meta-theory. His 43-day sprint proves that AI absolutely must be governed as an ongoing adaptive ecosystem. Continual learning, on its own, is completely opaque and unbounded. The Bridge360 model provides that missing governance layer, seamlessly interweaving Vapnik's weak convergence, Gödel's incompleteness, and Pareto efficiency into actual workable handshake protocols. It gives us a concrete domain to test these entropic rules in real time.
So practically speaking, what does this governance actually look like? Well, we need continuous provenance tracking, meaning we record not just what model was deployed, but what it literally just learned. We need a dynamic identity braid to track the system as it morphs. We have to run continuous adversarial perturbation tests, maintain granular rollback semantics to instantly undo an unsafe learning episode, and operate within strict thermodynamic bet windows. Governance isn't a static rulebook anymore, it's an active, continuous ecosystem itself.
I want to leave you with this final, provocative thought for our explainer today. If intelligence is no longer a fixed possession of knowledge, but an ongoing adaptive process running on chips designed by AI itself, we have to deeply rethink our ultimate goals. As these systems rapidly accelerate, are we still futilely trying to build a perfect map of the truth, or is it time we start building the corridors for our own survival? Think about that. Thanks for joining me on this deep dive.